Good morning. My name's Ashley Noble. Today I'll be talking to you about our group's transition to continuous delivery as a small group in a large organisation. I'll talk to you about the impetus for the change, the choices we made and the challenges we faced. I work for Honeywell. Honeywell is a Fortune 100 company, has 130,000 employees, 20,000 engineers and 11,000 software engineers. So as a company goes, it's on the large side. Honeywell makes a lot of exceptional products, but it also suffers from the normal big company challenges such as inertia to change. First, a definition. Continuous delivery is the ability to get changes into production or into the hands of users safely, quickly, in a sustainable way. For us, continuous delivery meant that we wanted to be able to commit our code and get it into production to get value from it, to get feedback as quickly as possible. Our team for the last 3 years have been working on an IoT platform. The IoT platform, like a lot of big companies, is our backbone for getting some of our products connected to the cloud so that we can add new and better services for our customers and provide better value to them. We've been working on this platform for roughly 3 years, but we're going to start our journey 2 years ago, which was a year after we started and when we realised that we needed to make a step change. So 2 years ago, we had 6 developers, one very large solution, a semi-automated build with hundreds of automated unit tests. We had a very manual deployment, which was PowerShell scripts, executing PowerShell scripts. We would, at best, deploy to a QA environment after every sprint. Sometimes we'd miss a sprint or two because we didn't have anything to actually deploy. It would take us hours to deploy. It would be manual steps. We would follow multiple wikis. We'd have tens of steps, and every one of those steps had to be followed in order and exactly. We would often find that we would find ourselves debugging a problem that we could trace back to the fact that we hadn't quite ticked one of the boxes or made one of the deployment steps that we were meant to. We cut a corner. We don't need to do that this time. Even if we got everything absolutely right in our deployment, it would take us days to test and validate. We'd be sitting there manually making sure that the new features worked, but also that we didn't have introduced any regressions into the product. From a build infrastructure perspective, we were pretty light on. We're using PowerShell Make, which is pronounced Saki, using Visual Studio Online, using its Git and build system. This is 2 or 3 years ago. It's not the Visual Studio Online that we know and love today. It was clunky, is probably the best way of describing it. And we're also using PowerShell to do our deployments. What we were deploying was a combination of Azure PaaS instances. We decided early on we didn't want to be standing up our own VMs. We wanted to go to the cloud and try and be cloud native. So we used Azure Active Directory. We used quite a few cloud services, which are worker and web roles, basically hosted IIS. We used a lot of service bus namespaces, topics and queues, as you'd imagine from an IoT platform. And we also used blob and table storage, sort of rounded out our PaaS infrastructure that we were using. So that's where we were starting from. Where we are now is we have roughly 15 developers spread across four main time zones. We have multiple solutions, which are totally automated builds with thousands of automated unit tests. We now have a fully automated deployment where we do on average 22 deployments a day, of which 3 of those are production environments. So this isn't exactly Google or Yahoo or AWS territory in terms of thousands of deploys today, but it's a good step along the way. We do so many deployments now that we don't even notice. There's no pain to do a deployment. We also have hundreds of acceptance tests that execute every time we commit something to our release pipeline. From our infrastructure build tools, we now have moved to the Atlassian tool stack. Really nice integrated set of tools. We use Jira for our issue tracking, Bitbucket for Git, Bamboo for our build system. We use Octopus Deploy for our deployments, LaunchDarkly for feature toggling, Artifactory for our package management, and Saki and PowerShell still. From our services, what we're actually deploying, we've extended somewhat. We now, as well as the previous services, we also now do native Azure websites. We use Cosmos DB, Document DB. We use a lot of stream analytics from Azure. We use event hubs, and we're replacing have replaced our service bus names and queues, many of them, with event hubs for the scale. and we also use Azure IoT Hub. So that's where we started a couple of years ago, where we are now. What was the reason for us to make the change? We knew we weren't working as well as we could be. We knew there was a better way. The catalyst for us was a book called The Phoenix Project. The Phoenix Project is a very non-traditional IT book. It's a piece of fiction. It's written as a novel. It's a story that you read. And the story aims to illustrate that lean practices don't just apply to manufacturing, they can also apply to IT. It does a really nice job of that. From this, we recognised we could sort of start to name some of the issues that we had. We needed to reduce our work in progress. We would often find that we had so many things going at the same time that we hadn't finished them by the end of a sprint or even the following sprint. In order to do that, we needed to do smaller work packets so we could turn them around faster, so we could deploy and get value to our customers quickly. And we also needed to automate everything. We know that we need to automate stuff, but how do we make it a priority? So this really pointed out to us that we had to make it a priority. The Phoenix Project also had a really nice reference to the next reference that helped us, which was the book Continuous Delivery. This is an exceptional book. It's really the Bible of continuous delivery. It describes all of the practices and the processes that you should or need to follow in order to do continuous delivery safely and sustainably. From this, we learned a few things. Like we learned what we needed to do, but then we needed to figure out how did we transition from where we were, which was very manual and quite clunky, to getting to continuous delivery. And we identified 3 main points that we could change. The first one of those was to move to continuous integration and trunk-based development. The second one of those was to build out a set of automated acceptance tests, not just unit tests that ran as part of our build, but acceptance tests that ran as part of our deployments. We also needed to build out a more formal deployment pipeline rather than just deploying something to dev, something to QA, and something to production, and they're not necessarily always the same things. So the first thing we tackled was continuous integration. And continuous integration for us was around also doing trunk-based development. Continuous integration, we thought we knew what it was. We had a CI server, we've been doing that for years. But we didn't really understand until we started digging into it about it's the fact that you're meant to integrate your code daily or even more frequently as possible. Everybody gets their branches and merges their branches down to a common central repository master every day. The idea of this is that if you introduce a bug, introduce an error that your tests are going to catch, then you can catch them very quickly. You've got a very small amount of code, a half a day or a day's worth of work, you can catch, that's a very small amount of code to trawl through to figure out where the bug is, and it's all really fresh in your mind. If you wait for an entire sprint's worth of work and then you try and find a bug, it's a lot more code to work through and can take a lot longer to find. Continuous integration also reduces the risk and the stress of a merge, of merging all of your code. Typically, at the end of a sprint, we would find that we were merging all of our code. We'd have several people trying to merge an entire sprint's worth of work at the end of a sprint. That creates a lot of risk, usually a lot of conflicts, and it would be a fair amount of pain. The first person that merged in, they were sitting pretty. Really, their code was the only new code. The second person that went to merge their code, if there was any errors, if there was any conflicts, they had to go through 2 people's sprints worth of code. If they needed to find errors, they had to trawl through theirs and someone else's code. The third person, they're pretty much stuffed. They had to go through 3 lots of people's code and so on. Whereas if we merge daily, then those daily merges, any conflicts, they're going to be small. They're going to be easily resolved, and you can just talk to the person that's just done it, and we can communicate, we can find them early. We can find out and fix issues very early on and adjust our plan so that we don't end up stepping on each other's toes. We also find that every process, this took us a little while, but every process is leaner. As an example, our code review process. After a little while, we realized that our code reviews were actually going a lot smoother than they used to be. And they're taking a lot less time. And we worked out that that's because we were used to doing our code reviews at the end of a sprint. We'd have in a sprint, a week and a half or so's worth of work that someone needed to review. If I was doing the review, I'd get presented with a very large pull request. Often I'd have to get that branch out in code and actually dig through it because it's really hard to do a lot of files in a pull request and understand the design. I might have been involved in the whiteboarding of the design, but then I needed to sit down and understand how it was actually implemented. When it was from that implementation, I needed to check that there was no bugs, the algorithms were correct, there wasn't going to be any performance issues, and it met our normal standards and criteria. And that would take roughly a day. A week and a half or 2 weeks worth of work could take me a day to review. It's a sort of a well-published fact now that the larger a code review is, the lower the quality of the review. So if we can change that cycle and do our commits daily, all of a sudden our reviews are also happening daily. All of the design issues that we might find, they're now found at the start of the sprint. And as the sprint goes along, the code reviews actually become shorter. So we found that maybe it takes me 20 minutes, 30 minutes to do a review near the start of the sprint. Towards the back end of the sprint, maybe it's only taking 10 or 15 minutes to do each day's worth of review. That's because they're mainly fleshing out code, adding tests and error handling, that sort of thing. It actually becomes a lot quicker. So then when we get to the end of the sprint, there's no stress. There's no 2 or 3 day cycle where you're iterating over big reviews and big change sets. So there's a lot less stress, and the last sort of review is really just almost check the box. It's much easier. So we've dramatically reduced the amount of time that it takes us to do a review and reduced the stress. Sure.
Sorry, so basically you're saying you're working daily. How does this affect your pull requests and user stories? That would be a fair number of pull requests per user story? Or?
Yeah, so the question is, how does merging daily affect our pull requests and our stories? So as part of continuous integration, the idea is that you do multiple pull requests per story. So you'll have the same Jira or whichever tracking system you're doing, the same request will be committed to multiple times, and you'll have multiple pull requests for that. So you're not closing out an issue until we've made the final sort of commit. So you end up with multiple pull requests, and they're much shorter. The other area that this addresses is that right at the end of the sprint, someone's been working for a week and a half, and you look at the code and you say, this wasn't the design that I intended. You've made a mistake. Sorry, you can't commit this. Like you're going to have to start again. That's really demotivating, and you've lost an entire person's worth of work for the sprint. And maybe it'll be quicker to do again, but really you want to find that stuff out earlier. So if you can watch, if they're committing code and you're doing reviews earlier, you can catch those sort of design issues much earlier and make sure that you actually capture the value at the end of the sprint. So that's how our code reviews, just an example of the processes become a lot leaner. And this happens across the board for many of the processes. So this is what continuous integration is and some of the things we learned. We were starting from Git flow. Git flow is pretty much the opposite of continuous integration and trunk-based development. It's a very formal and strict process. I'm not going to try and describe everything that goes on here, but there is a process for every step. Creating, when you start the feature, how you merge that down into a dev branch, how you create releases. Those releases then get merged down into something that gets deployed to production. When we were doing manual steps, that was sort of okay because we could do this manually, but we wanted to move to something which was much faster. We wanted to do continuous integration, and we didn't really see at the time how we could use continuous delivery with Git flow. Now, after doing continuous delivery for a while, we could squint our eyes a bit and say, yeah, I can understand it's maybe possible, but I still think this was going to create a lot of headaches for us. So what we moved to was continuous integration-ish. Okay? It's a journey, and we're not there yet. It's both a process and a cultural change for the team. And it's taking us a while to work through this. To do continuous integration and trunk-based development, which means always merging into master, taking a feature branch and merging into master, it really pushes the done is done philosophy for the team. It raises the quality bar because the next time you merge, you're merging to master, and that is going to end up in production. So if you haven't written enough tests, if your automated tests don't catch a bug, it's going to end up in production. And that raised the bar across the team. We don't have any metrics around this, but we noticed as a team that we were injecting far fewer defects downstream. We didn't have a test. We no longer needed a test team, so we weren't catching them. We weren't capturing those defects, but we were injecting far fewer. The developers and the code reviewers were doing a more comprehensive job. We pushed quality to the left. So it's but changing to continuous integration, we did trunk-based development. Doing daily commits is a bit of a challenge. It's a process and a cultural change. If it was a continuum between feature branch development, where you merge at the end of the sprint, and continuous integration, where you're merging once or twice a day, our teams at the moment fall somewhere in the middle there, and developers fall somewhere along that line. There's Kent Beck put a tweet out recently, which I think really clarified this for me. You can't effectively address cultural problems with process, just as you can't address process problems with culture. We were trying to change the process and the culture, and we really only thought about the process. We changed the process. We didn't do enough to help the teams work around to improve the culture. As an example of the culture that needs to change, is that everybody has to be happy to work in faster cycles. You have to be able to commit your code every day. You need to be able to do code reviews every day. You can't just say, I'm going to work for a week and a half and then I'll do reviews for someone else. Okay? You can't just leave the code reviews to the end. You can't beaver away and ignore code reviews because you're blocking someone else. So we needed to change the culture of the team. The team also had to learn, the team also had to learn new skills. So they had to learn how to create work packets that could be merged in a day that made sense. You don't want half-tested code committed every day. You need to work on a logical piece that made sense, that could be committed, so that when you're merging with everyone else, it made logical sense. That's a skill that people need to learn, and various people have that skill, and various people needed to learn that. For example, some people needed to learn how to build effective thin slices, so to build a thin slice through their code. Other people needed to learn how to build individual modules and then connect all the services together. So there's skills and techniques that the developers had to learn. The developers also had to, another thing that got in the way was developers had to make sure that their build and test processes were running fast. So the faster you can get feedback that you haven't broken anything, the faster you can commit to master and get into production safely. So if your build and test process takes 10 minutes, then you could perhaps merge to master every hour or two, because there's not a long amount of time to wait for feedback. However, if it takes a day to get a build and for all of your tests to run, then there's no sense merging every hour or two, because you have to wait a day to find out the results of that. So you push your times out to multiple days before that sort of you get the reward, and it makes it worth committing the code. We fall somewhere between those two. At the moment, it takes us an hour and a half for some of our components to give us results and feedback. So for us, that works out to be about a day's worth of effort is about right. It takes about a day's worth of effort. An hour and a half later, we can get some verification that what we've added is successful or not. So we've simplified our development flow. We've reduced our merge conflicts and risk. Now we have to automate our build and our deployments. The first thing, the traditional software problem, is we need to break up our monolith. We had one very large solution that came from a year of beavering away, adding features, showing that we could build this product and it was going to add value. Then we knew that we had to make a step change, and this is the start of the journey. So we had to split apart our monolith. Microservices are all the rage now. They were all the rage a couple of years ago. When we looked at what we needed to do in order to get to microservices, it was going to take us a few months. Our code, if we squinted, we could see, like it was reasonably well structured, we could see how we could extract it out into a full microservice-based architecture. But it was going to take us a few months to get there. And from a product owner perspective, it was going to be a hard sell. We promise we're going to go faster. We're just going to take 2 or 3 months, do nothing, add no extra value in that time, and then we'll be able to deliver much faster. That's a really hard sell. So we sort of went somewhere in the middle. We broke our code up into 6 or 7 groups, components that encapsulated several services that were logically deployed together. We did just enough, and to some extent, we hid the cost of doing this from our product owners, where we would say every sprint, every developer was spending 2 or 3 days doing a deployment and validation and testing. So of all the manual steps, that adds up to 12 or 18 days per sprint of manual work. We figured over 2 sprints, we could probably use that time to fully automate our build. And that's why we cut it down to 2 sprints. And we said, okay, this is how much we can split apart our code. So we made some practical decisions there around how much we wanted to break up our code. So we broke it up into 6 or 7 components, mixture of library and application code, and the solution where we had project references, we used NuGet packages to share the code that we needed to reference downstream. We also had to do a bit of tweaking to make sure we didn't have any circular dependencies, but we used NuGet in order to break the dependency cycle. Of course, now we needed a way to store and retrieve our NuGet packages. At the time, the company didn't have a general solution for storing NuGet packages. There was a few people who had a few build machines under their desk which hosted a local instance of NuGet. Anyone who's used that style knows that it doesn't scale very well. We found that out, and also it doesn't take very long to find out that it is incredibly slow after a few hundred packages. So initially we started with MyGet with private repositories. We couldn't use NuGet.org because we really didn't want to be publishing our private company code out into NuGet. So we used MyGet with some private repositories. MyGet's really nice, really recommended as a service. It has some great UI, really nice package management features, and good user management. Through our transition, we moved to the Atlassian tool stack. As part of that, one of the infrastructure teams stood up Artifactory. Artifactory, not as nice, not as good, not as many features, but it made sense for our organization with the number of different types of containers, number of different packages and package management systems it could support. It also was running within the corporate network, which meant that I didn't have to field so many questions around our code is in the cloud, and that was being able to bring it back and not have so many audits, security audits around where our code was. That was nice. Okay, so now we know we're building packages. We need to get our packages into a repository. What on earth are we going to do? How do we version them? I've never been a fan of the build machine having write access to a Git repository. And I don't like the approach of tagging every time we do a build, putting a tag on Git, on a Git commit. So we used a tool called Git version. It was designed originally for Git flow to support the Git flow mechanism to help version that. But Git version also can be applied to trunk-based and feature-based development. For us, Git version calculates a build number. So rather than taking it from a tag, it calculates it from either a stage where you've merged in some code, or from a tag further down. And so if you check the code out a year later, it's exactly the same version as it was at the time. So it's nicely calculated, which means we didn't need to give write access to our repositories for a build machine. So we've split our build up. We've made multiple components. We've figured out how we're getting them into NuGet, and we're versioning them. The next step was we needed to be able to deploy them. And for each of those components, we needed to deploy them. We chose Octopus Deploy. For us, this actually became an easy choice. We had a cloud architect who joined the company about the time that we were making this choice. He had a lot of experience with various types of deployments. We said, what should we use? Should we use Chef or Ansible or Puppet? He somewhat surprised us and came back and said, using .NET, you're using Azure, just use Octopus. And at the time, we were trying to figure out how we were going to break up all of our builds, break up our deployment subsystems. We were happy to take someone's straight up answer on that. So we didn't need to go through and analyze all the rest of them. Octopus was great, solved a lot of problems for us. It's great value for money. It has very nice support. Every time we've asked a question, they give us very quick and useful feedback. It has some very nice dashboarding features. And best of all, it allowed us to build in single-click deployment. What we did for each of the components, we turned them into a deployment in Octopus, and we had the process steps within Octopus execute pieces of PowerShell that we'd been executing manually before. And the steps that we had been executing manually, we figured out how to automate those, and we also ran those steps inside Octopus. So then, all of a sudden, this one change where we could turn all of those steps into an automated process, it did two things. It took away hours of time every time we needed to do a deployment of watching it and sitting there and running through steps. And it also reduced the number of manual mistakes that we were making. The mistakes we made, the amount of time that we spent chasing down phantom issues because of a deployment mistake, all of those went away. This saved us an enormous amount of time. What we have to do is say, deploy this release to this environment, and we're off. Octopus has a number of other really nice features, and it implements something akin to the configuration repository, which the continuous delivery book talks about a lot and recommends and says that's an essential part of continuous delivery. A configuration repository is something where every time you do a deployment, it pulls the configuration from the repository and applies that to the deployment for that environment that you're deploying to. It should have a number of features, such as very good security. It should have auditing, and it should have versioning, so that you can go back at any point in time and deploy the same thing. Octopus solves this using its libraries of variables, variable sets, and environment scoping on variables. Octopus also allowed us to do immutable releases. So an immutable release is where a set of binaries and a set of configuration come together. That's a release that we deploy. If you change the configuration, that's a new release. If that change in configuration breaks everything, you just simply go back to the previous release, deploy that, and it's exactly what it was before. So the versioning of configuration is a really important step to allow you to roll forwards and roll backwards. We used Octopus as well to help build our release notes. Every time we did a build, we'd create a release in Octopus, and that release would include the git commit hash so that we could trace back to exactly where that deployment came from. We also included the git commit comment and some metadata such as the Jira ID or the tracking ID so that we could go and look at what was the reason why we were making those changes. So those sort of release notes helped us to solve some of the issues that we had with our release management team. Honeywell's a big company, it has a lot of processes, and release management is high up on its list of important processes. A little while after we'd started using Octopus and been doing our deployments, a release management team came along and said, hello, we're your release management team. We said, hi. They said, we're here to make your releases better. We said, okay, great, thank you. How are you going to help us? So they said, well, what we're going to do is we're going to set up all of these processes for you. We're going to have monthly change control board meetings where we go through and approve every change that you're going to deploy in the next month, which means you need to know what you're going to deploy in the next month. We want to know your release dates. We also want to know when you're going to have downtime, and we also want handovers for all of your scripts, of your deployment scripts, so that we can run them for you. We scratched our chin a bit and tried to explain that we were trying something new. We were trying something called continuous delivery. We aimed to deploy to production multiple times a day. So they came back and said, that's great. We're going to have monthly change control board meetings. We'll need to know all of your scripts in advance. You can see how that went. So after 1 or 10 meetings, we sort of managed to turn the ship a little bit. And we managed to influence and come to some agreements where the release management team's requirements could be met, the intent of their requirements and not necessarily the processes that they had, and ours where we wanted to be able to deploy as frequently as daily or even more often to production. And we did this by defining 2 sets of changes. And this is some typical ITIL terminology. We were using standard and non-standard changes. But we defined non-standard as anything where we had to stop or take some downtime in order to deploy. So if we were upgrading or changing our infrastructure, then that would require us to stop some services to do a deployment. Or if we were doing a database change, which was one way, where we're going to need to do a database migration, even if we were doing it on the fly, we still needed to do, that would still be considered a non-standard change. Now we only do 2 or 3 of those a year, so that wasn't such a big deal. Everything else was considered standard, and we got it to the point where anything that was in a sprint plan on our Scrum board that wasn't one of those non-standard changes was considered automatically approved. So we managed to sort of weave our way through the release management process to meet their goals and ours. Some of the things that the release management team really liked about Octopus is they really liked the auditing capability. They liked being able to see who deployed and why. They liked being able to see what was in every release. So the tooling really helped us there. They really loved the single-click deployment. So when we showed them this, often we're on a telecon, you could sort of hear their jaws hitting the table as they're like, what? It's a single click. We don't have to run through scripts. We don't have to do all these manual steps. Pretty much like we were doing before. They were often thrown those things to do deployment. So they were really pleased about having all of this behind Octopus Deploy. One thing that they were concerned about was how was our test team going to keep up? How is our test team going to keep up with the deployments every day? How are they going to be able to say, yes, this is a good build? Our answer for that was that we created automated acceptance tests. We used executable specifications using a tool called SpecFlow, very similar to Fitness and other similar tools, where we would write prose. We would describe what we were doing in text, and then there was code behind which took those this domain-specific language and turned it into steps which were executed against a deployment. So this wasn't executed against build time, it was executed against something that we deployed. We'd used SpecFlow before, we were familiar with it, and it's a really nice way of describing, particularly for a platform, which is basically just APIs and messages, the intent of each feature. So if we wanted to know what a feature did, we could just have a look at the acceptance test that the developer was writing. Executable specifications do have a learning curve. There is sort of an impedance mismatch between the nice text that you write and the code that's running behind the scenes. It does take constant vigilance to make sure that we don't end up with sort of spaghetti code or duplicated code behind the scenes. The challenge we faced once we started writing acceptance tests was around our execution times. How long was it taking to get feedback around our acceptance tests? We started off, we had a few tests, proof of concept. We added a few more tests. Yeah, this is great, but it's running a little slow. Let's do some local improvements, get it back down to a reasonable amount of time. And we said, this is working really well. Let's add tests for everything in our platform. So together as a team, we had a whole sprint where all we did was write tests. Now, we didn't try to go for 100% coverage. We had automated unit tests as well. What we did go for was 100% happy path coverage. So every single API and message needed to have at least one test through it to make sure that everything was integrated. And we let the automated unit tests handle the rest of them. We also did some of the more important sad case scenarios. So every happy path and some of the sad paths. Of course, the predictable happened. It took an enormous amount of time. All of a sudden, we had hours and hours of acceptance tests, actually nearly half a day worth of acceptance tests it took to run the tests, which has all of a sudden slowed down our feedback loop. And sometimes if there was failures, it would take even longer. So our feedback loop has just stretched out from where it was when we started, about 15 minutes, and now we're at about an hour. But when it was half a day, that's just simply too long to be able to get effective feedback. So we bit the bullet, the choice, and we said, okay, let's run everything in parallel. SpecFlow is a really nice tool that allows you to run things in parallel, allows you to specify some parameters around it, how many things should execute at once. It collects the feedback in a really nice way. So SpecFlow really supports running in parallel. And so we managed to drag our time down back to a reasonable level, and actually came down to about 20 minutes. Unfortunately, we were running so fast that we started running into transient problems. So we needed to slow our tests down, and that's why we're back up at around an hour to execute our tests. We had to slow them down. We were running into transient failures where a test would fail in one spot, you'd retry, it'd go away. You'd run another set of tests and it'd fail in a completely different spot, in unpredictable places. This really crept up on us. We were, as our code and our tests became more complex, we started off where we'd see a transient failure maybe 1 out of 10 times we were running a test. And developers just, okay, let's retry, see if this was transient. After a while, it was almost 1 in 2 times it would fail. Every second time we tried to run a test, we ran our tests, it would fail with a transient failure. And developers just got used to just clicking retry. And we realized that we were actually, even though the tests might be executing in a certain amount of time, it was more twice or 3 times that because they were just hitting retry. When we recognized that problem, we were like, yeah, we really need to look into this now because we're trying to add new features, but this was starting to slow us down. So we looked into it, and unfortunately it turned out to be one of our PAS components, Azure Active Directory, which is causing us the problems here. There was 2 ways that it caused us problems. We'd written really nice isolated acceptance tests. Every test, when it started up, it created objects in Azure Active Directory and set up the permissions in order to be able to use those objects. And then our test would run and use those permissions to execute all of the tests. Now what would happen was all of those tests are running at once, and so we were effectively load testing the write path to Azure Active Directory. It's really optimized for reading, and we were putting so much load against the writing and the updating of permissions that they started throttling us. And particularly as we got more complex, the throttling got more severe. And even with exponential retry backoffs, we would still lose enough of the messages that some of our tests would fail. So to address that, we had to take away some of our nice isolation. We had to change it so that all of our tests, at the start of the test run, before it did anything else, it created a common set of permissions, and then we would share out those permissions to each of the tests as we stood them up. And that felt a little bit dirty, but we really didn't see a way around it at the time. The other problem that we faced was around Azure Active Directory's eventual consistency. It's a very largely scalable service. It can scale to millions of objects with the permissions and references in between them. However, in order to do that, it has eventual consistency. What it does is when you make an update, it makes that, it then replicates that to all of the other services in the same data center and other data centers. Unfortunately, it's really not a trivial amount of time. After talking to Microsoft about the issues we were seeing, they came back with some stats along the lines of it takes roughly 2 minutes for most changes to replicate around the globe and around even into the same data center, and 4 minutes for almost all, 99.999% of changes to be replicated. That's a non-trivial amount of time, and it meant that for us to be confident that our acceptance tests were working correctly, we had to add a 4-minute delay at the start of all of our tests and any time within our tests that we did something which changed permissions. And there were quite a number of tests which changed permissions 1, 2, 3 times throughout the tests. And so we would end up with a 12-minute delay where we just sat there twiddling our thumbs, waiting for that 4 minutes because there was no way of knowing if the permissions had been replicated everywhere or not. We're still working on solutions for this, but this is the reason why we had to slow down our acceptance tests. And it's sort of one of those pragmatic decisions about, well, do we keep hitting retry or do we just slow it down and be more confident? So the release management team, they were happy with where we were going, and they were particularly happy when we said that we'd got coverage across all of our functionality, the happy path across all of our functionality. They still were interested in what our QA team, how our QA team was going to let the release management know when it was okay to deploy to production. For us, that was a relatively straightforward answer. We didn't have a QA team. We no longer needed one. when we were doing our manual steps and doing our manual testing, we actually started onboarding some test teams, a test team, and we had them starting to learn how to execute the tests. But that was right at the start of when we started this journey. As we were making this journey, it turned out that we actually didn't need them to be running tests anymore. Every test that they were running was easily done with the acceptance tests. So what we did was they became some of our DevOps people. They became good at doing automation and helping us actually improve our processes rather than sitting there and writing tests anymore, or running the tests for us. So this is good for us. We've been happy that we don't and haven't needed a QA team up until now, even still. So we've got our tests in place. We've got our builds. We've got our deployments. Now we need to set up a pipeline. That was the next step along our journey. The continuous delivery book has a lot to say about pipelines. It talks about what they are, the need for them, and gives some samples. We pretty much adapted ours from one of their more simple samples. And a pipeline works along the lines of each column is a stage, and you progress your release across from left to right, going from one stage to the other. And if it breaks at any stage, then that release is dead. It's not allowed to be promoted to further on to the next stage. Typically, if anything's going to break, it's going to break in the acceptance tests. And that means we need to change code or change configuration in order to get a new release that we then get through the pipeline. A description of our pipeline is we used to have a lot of deployment failures, particularly when we were trying to guess at the REST interfaces that we should be using to deploy our code. So we used a deployment canary to a very quick deployment to find out if there's going to be any deployment failures. We probably don't need this anymore because we very rarely have a deployment failure. However, we execute this. If that passes, if it deploys, that's all it does. It then moves on to the next stage, which is the acceptance tests. We execute our acceptance tests. If there's any failures in there, then it can't go any further to the pipeline. We don't run our acceptance tests in every environment that we go to because A, it takes a long time. It takes roughly an hour to run. And also, if there's failures, we haven't successfully managed to make it so that there's no sort of pieces left over. We don't manage to successfully clean up everything if there's failures. So we sort of leave that murkiness in that acceptance test environments and occasionally go through and clean those up. Assuming that our acceptance tests pass, we then move on to the QA stage, which is where we do our load testing, security testing, and where we have our sort of traditional QA. We don't do automated load testing at this point. That's something that we're getting to. We're on our plans and to be able to execute a set of load tests. Our traditional QA, well, we actually don't do anything there. All of our tests are running over in acceptance tests, and QA is where other applications that are using our platform play. It's sort of the Wild West where they're learning to use our platform. They try and stress it. They try and break it. And so that's a really nice place for us to learn and build in some resiliency and robustness. We find out about the things that we need to take into account so that they don't end up then in production. From QA, we then promote to production. And this is the one manual step in our process. We have one manual control. And it's a bit that says that we're continuous delivery, not continuous deployment. Continuous deployment is where you have a completely automated pipeline from code to production, no manual steps in between. Continuous delivery is when you have at least one step in the one manual control in the way. Our manual control is we actually wait 24 hours. So we have a release come into QA, 24 hours, we manually promote that to production. And what we look for in that period is we look for any alerts or integration issues that have happened on any of our QA environments. If there's anything that happens that would prevent us from deploying to production, then we don't deploy. This doesn't happen very often, and so now we're in the process of changing these steps to be an automated deployment. So what we're going to do is we're setting it up so that we're going to wait 4 hours and automatically look at those environments and see if there was any alerts or incidents, and if there wasn't, then we'll deploy to production. So we're just about there to getting it to being a continuous deployment rather than continuous delivery. So how do we know that the code that we're running in our acceptance tests will work correctly on our productions? And for us, we have production-like environments everywhere. The infrastructure for every environment, from testing all the way through to production, is exactly the same. The only difference is scale. But we use the PaaS services, and everything is exactly the same all the way through. We do this so that there's no sort of works in this environment, and it doesn't work in this other environment where they're slightly different. One of the rules that we have, though, because we're deploying, we deploy over top. We deploy to the same environment over and over again. Azure does a really nice job when you've got a lot of instances running of making sure that everything stays up by stopping one, upgrading it, starting it, stopping the next one. Azure does a great job for us there. We very rarely see downtime. But what we do have is long-lived environments, long-lived infrastructure. So something that we need to take care of there is that we don't end up where someone manually modifies something through the portal and all of a sudden we're out of sync. So we have some very strong rules around what we can and can't do. And from the portal, it's pretty much the rule is you cannot make any changes. And we restrict, we take it as far as for our operational teams, they have no ability to make any changes to production. They're the only teams that can see production apart from a couple of the DevOps members. And they have no ability to make changes apart from occasionally restarting a server if that's what the runbooks call for. Our developers have no access to QA or production in order to make any changes. The idea behind that is that if the developers are not going to have access to production, so they may as well practice on QA, not have access there, so that they can learn what instrumentation, what tools they need to build to be able to support the platform. So developers have no access to QA or production, only the DevOps team. If a change needs to happen to infrastructure, it has to happen through the deployment scripts. It has to happen through the deployment scripts or through Octopus configuration variables. That's the only way we allow a change, and it has to be through a deployment. So far, this is working out pretty well for us. So this is our release pipeline. Just work through our release pipeline. What do our developers see? They have a much smaller pipeline. And the developer pipeline is along the lines of they make some changes, they create a branch, make some changes, push those changes to the central repository. Our build server sees those changes, creates builds the artifacts, creates the deployment artifacts and pushes them at Octopus and creates a release in Octopus. And at that point it stops because we're not really sure, we're never sure that the developer actually wants to deploy their code at that point. They may be just asking for an informal code review. So we stop at that point and we allow the developer to then go and click on that release, click the button and deploy to one of our environments. When they deploy to that environment, it executes all of the acceptance tests. So not only do the acceptance tests run as part of the release pipeline, they run across whenever the developer's deploying for their testing. So if we put all that together, our flow for a development process looks something like the following. A developer creates their feature branch, as I just described. They push their changes. That kicks off the build machine, which kicks off Octopus to create the releases. And the developer then tells Octopus to deploy that to Azure. That executes the acceptance tests, and the developer looks at the results of those acceptance tests, and our deployment fails if the acceptance tests fail, but they look at the results, make sure that all the features that they expected that their tests ran, and then say, yep, that's great. So they go and create a pull request. A code reviewer makes sure the build worked, they make sure that the acceptance tests succeeded, they review the code and say, look, this is a great feature, I think this is going to be a great add, this is approved. So they approve it, and then the developer merges to the master pipeline. And that hits our release pipeline, where we follow the same build and deployment. But this time, when the release is created in Octopus, that automatically kicks off the pipeline so that it goes to our deployment canary. If it passes there, it goes to the QA pipeline. It goes to acceptance tests and then the QA stages. So it's totally automated from that point on, all the way through to QA. So this is a description of the process that we follow and most of the tooling that we used. There's one tool that we found out about last year at this conference, which is Launch Darkly. Launch Darkly is feature toggling as a service. When doing continuous integration, you want to get the advantage of integrating frequently, but you don't necessarily want the code that you're integrating that you may only have a partial solution for running in production. Feature toggling is a solution to that, where you can make sure that it's turned off in production until you're ready for it. Launch Darkly, as I said, it's a cloud-based service. It's exceptional, it has a really nice UI, has great auditing, which is important for our release management team. It's very secure, it has clients in a lot of different languages, and it has additional support for things like dynamic toggling. When you change a toggle, it'll stream that down to the clients that are listening, and they'll make those changes at the time. It also has user-based and A/B style toggling as well. So you can say, this user should be allowed to have it. So in production or in QA, you can turn on a feature for a particular user. The A/B testing, you can say, I'd like sort of 2% of my calls to go to this toggle and 2% with the toggle off. It's a nice way of getting back the feedback from your customers. So we had a basic form of toggling before we came across Launch Darkly, but it was deployment based. We'd make a change in our configuration in Octopus and then deploy it. So it was either on or off. It was very slow, and we couldn't effectively manage it. With Launch Darkly, we had the ability to create now 2 different types of toggles. We could create dev toggles and operational toggles. We could create the developer toggles were around a feature that we were implementing, and when we got to the end of the feature, turn it on in production, we'd then strip out that toggle and take it away from the code base. Operational toggles allowed us to turn on and off entire features that were that maybe the customer doesn't need those features, something that we decided in advance that a customer may or may not need in the environment that we're deploying to. Launch Darkly also has a really nice set of APIs. So what we do in the APIs is when we do a deployment, we go to Launch Darkly and say, have you seen this environment before? If it hasn't seen that environment before, we create it. We also have a list of all of the feature toggles that are in the code base at that time. And so it goes and updates Launch Darkly with those feature toggles so that we don't need to go, the developer never needs to go to Launch Darkly and type in a feature toggle, all the manual entry issues that could occur there. So we use the APIs in order to set up and automatically configure our environments in Launch Darkly. So when we put all of our tools together, over time, we've gone from a very small tool chain into a much larger tool chain and a much more mature set of processes. When we look at all of these tools as they're joined together, our CI/CD pipeline, actually, when you look at a high enough level, most people's CI/CD pipelines look pretty much the same. We could replace Bitbucket with Git, Bamboo with Jenkins, Octopus Deploy with Chef or Puppet, Azure with AWS or Google. They all look pretty much the same. The only thing that I'm pretty confident at the moment that you can't replace is Launch Darkly. Like, it provides such a nice set of features that I don't know of another replacement for it. So this is how our tool chain hangs together. We've got our continuous delivery. We're not as fast as we'd like. We know there's some things that we want to improve. But what's next for us? Well, fortunately, someone wrote another book. In fact, the authors of the other 2 books got together and wrote something called the DevOps Handbook. This is a really nice reference that includes a lot of the information from the continuous delivery book in the first half, but then it extends it and moves towards operations. So it talks about how you should manage your product in the entire life cycle. Continuous delivery was around how do you get it deploying. This is about how do you manage it. And there's some things in here that we thought about that we were like, yeah, this makes a lot of sense. We'd really like to do this. We really want to be able to add some more metrics and dashboarding to our application so we can track it. We're an IoT platform. We have a lot of stuff going on, a lot of load going through it. How do we see how it's performing at each point? So we really want to improve our metrics so that they're a little bit more fine-grained. We want to add more instrumentation so we can do some predictive log analytics. So the DevOps Handbook talks about how you use predictive log analytics to figure out when you may have a problem coming. You can do some analytics on it, And that sounds really interesting from a computer sciencey sort of perspective, but it'll also be useful for operations if we can get in front of problems that are starting to occur. Along with improving all of our existing processes, where we desperately want to speed up our acceptance tests to reduce that feedback loop. We want to improve our build speeds. Our builds running at somewhere like 20 minutes as well. We'd like to get both of those things down to around 10 minutes. We're thinking about ways that we can do that. For our development environments, we also want to stand up dynamic development environments. So at the moment we have a very fixed set of development environments, and that works well from making the developer think about migration at every step. So if they know they're making a migrating change, the first thing they have to do before they can deploy to anything is address that migration. That keeps it in the front of their mind, but it also means that we have sort of these long-lived environments, and very occasionally we find that someone's made a change which doesn't work when we stand up a completely new environment, that those changes it may not work. So we want to be able to stand up sort of dynamic environments and test them from scratch. There's a lot more to do for us. So for us, building a CI/CD pipeline was a journey. We're only part of the way along that journey. We made incremental steps towards that destination, and we don't think we're there yet. We know we've got a long way to go. We know that there's a lot of things that we want to improve, and I'm not sure that we'll ever be finished this journey. So that's all I've got time for today. Well, that's all I had prepared. We've got a little bit of time if we want to take some questions. Otherwise, I'll take some questions outside as well. And also, I'm around for the rest of the conference if anyone wants to chat to me, because I love talking about this sort of thing. Yeah.
So for feature toggling, how you make sure you clean up the code regularly? Like, is it a manual thing? We look, yeah, we're not using these switches or these feature toggles.
Yep.
We just want to change the code.
Okay, so the question was, how do we make sure that we clean up our feature toggles? Is it manual or is it automated? And it is a manual process, but actually Launch Darkly helps us with that as well, because what we can do is we go through Launch Darkly every now and again and look, and it tells us when the last time a toggle was used. So we can see, well, this toggle wasn't even queried. The code didn't query this toggle in the last month. So that makes it easy to clean up. And we go, okay, now we'll write some code. We do want to adjust our code so that it automatically deletes them, but we haven't got there yet. It's on our list of things to do. So at the moment, that's a little bit of a manual step. But Launch Darkly helps us to identify them. Yeah, question?
Just a question on process. So do you carve out time each sprint to work on these improvements, or do you find it's better to just say 2 sprints of no value, like you said, no value, but get payoff?
Okay, so the question was, do we carve out time to make the improvements here? I talked about the fact where at one point we sort of hid some of those improvements. It's sort of a combination. We use it as some developers will sort of think of an idea or will talk about an idea, and some developers sort of do it on the side. But things which are a bit bigger, like turning our acceptance tests into parallel tests, that we try and carve out time for. So it really depends on, it's sort of a mix of priority for us, priority for the product owners. If we can really show value to the product owners, then we include it. If it's something that just makes our lives a little bit easier, but product owners may be a little less excited about it, then we may do it as sort of a background or a sort of a hidden sort of thing where we do it outside hours or as a background task. Yeah.
I have a question about how you mentioned a little bit at the end about how do the developers support the application? How do they know what's happening in production? So you said the devs don't have access to production. So how do they know it works great in my dev environment, but when a million customers hit it,
Yep. Okay, so the question is, how do the developers, they don't have access to production or QA, how do they know what's going on? How do they know whether it's working, the features are working, the environment's working? So we use a couple of other tools. We use AppDynamics and we use Splunk. AppDynamics provides the application monitoring for us, and Splunk provides the logging. And our developers have access to those tools, so they need to add instrumentation so that they can effectively track their features through the code. And AppDynamics is sort of an application monitoring tool that tells us when we're throwing an unusual number of exceptions or any exceptions, or all of a sudden seeing a spate of unauthorized calls, that sort of thing. So AppDynamics helps us there.
So, but let's say your application throws these errors
Yep.
at 1 a.m. Who wakes up?
Okay, so that's a different question. So if our application starts throwing errors at 1 a.m., who wakes up? We're a big company. We have a team that's allocated who is watching for those sorts of things. When I mentioned that we have a team that's running across 4 time zones, we actually have teams in Argentina, Australia, Beijing, and India, 5, and North America. And so there's usually someone awake as well. So there's usually someone who's available to answer that. Okay, we're out of time, but if there's any more questions, I'll just be outside. I hope this has been interesting. Thank you.